Hey guys, it's Mr. Sheeline here. This is going to be the video that's going to be that extra help video when it comes to scientific notation that you guys really need to watch if you're still struggling with scientific notation. Okay, so if you haven't already, just because in the sequence of how I'm posting these, if you haven't already watched the sig figs video, even if you think you know everything there is about sig figs, even if you think you're a master at them, go ahead, go and watch it if you haven't already, because really you need to know everything there is that I can give you about sig figs before we move on. If you're ready to go, let's just get straight to it and really get into scientific notation here. Okay, really not getting back into it. It's just going over what I saw as being the biggest issues that I saw both in the quiz that you guys took the other day and what I've just been grading so far. So, what I've seen so far is a number of things. One of them being is knowing what the number of sig figs are when it comes to scientific notation, which is something I did talk about in the last video, but real quick, to touch on it again, if you have a number that looks like this, if you have a number that's like, 4.63 times 10 to the 6th power, if you have something that's like 5.012345 times 10 to the 1000th power, if you have something that is just 4 times 10 to the infinitieth power, remember the only things that we really care about are these numbers that are not associated with the times 10. Okay. The times 10 and exponent, we don't count that as our sig figs. It's these values right here. So 4.63 is going to be 3 sig figs. This whole big guy is going to be 1, 2, 3, 4, 5, 6, 7 sig figs. This guy is just going to be 1 sig fig. Okay. We don't care about this. So always keep that in mind, that if when we're multiplying or dividing, significant figures against one another, when we're doing that, what we care about at the end of the answer is the lowest number of sig figs according to this part of the scientific notation. Okay, so that little recap. Let's now just go to it. So the second biggest thing that I saw an issue with, and arguably it is it is the biggest thing. If I said the other one was the biggest, I didn't mean that. This is the biggest issue I've seen you guys have. It's taking or putting things in scientific notation that are already in incorrect scientific notation. So if you've got something that's like 0.924 times 10 to the 3rd power, I ask you to take this number and put it in correct scientific notation. And there are multiple ways that we can do this. So real quick, we're going to go through 2 ways that I do kind of mention and go through in the notes, but here I'm going to do it again. The 2 ways that you can do this they're both fairly simple. One takes a little bit more work, but it's a bit more straightforward. It gets you to the really it gets you to the answer much more. In my opinion, it gets you the answer much more clearly. The other way we can do it is also good. It's just a little bit more abstract, and so it's possible that you may make a mistake more often using this method. The second one. So the first method that we would use here is just getting rid of this guy. So it's basically we're going to take it out of scientific notation and then put it back into scientific notation. So let's go ahead and put this guy, or take this guy out of scientific notation. So let's take the decimal here, and it says that we're going to make this guy bigger. So by 3 jumps. So let's take that decimal and we're going to go 1, 2, 3, moving it 3 places to the right. Okay. So that we are left with something that's 924. Okay. Then what we're going to do here is put this bad guy back into scientific notation. So we're going to find that decimal place, and then we're going to move it to where it needs to be, which, as we know now, when we write scientific notation, it needs to look like this. We have to have some sort of value here, decimal, and then whatever comes after. So we're going to move this decimal 1, 2 spaces to the right, or sorry, to the left. And so when we put it back into scientific notation, when we move it to the left, left we add, but if we go right, we subtract. So because we moved to the left, it's adding. So we were going to add 2 spaces. So that's going to give us a positive 2. So we would have 9.24 times 10 to the second power. Okay. So that's one method. Another method is this, using the same number here. It's again the more abstract one. It's less work, but again, it is you may trip up more often. You may make more mistakes doing this just because it does take a little bit of work in your head, more than it does with this. I would argue the first method I just walked you through. So with this method right here, we've got 0.924 times 10 to the third power, and we need to put this into correct scientific notation. So we would think of it this way. Even though it's in scientific notation, we're going to have the attitude in the mentality that we're going to put it into scientific notation, or at least we're going to follow those rules. So what we're going to do is we're going to take the decimal, we're going to put it where it needs to go, which is going to be between the 9 and the 2, because we want it to look like this. Okay, well, and then the times 10, obviously. But we're going to follow the rules that we lay out for putting it into scientific notation. So those rules are LARS. What I mentioned in the other scenario. You move it left, you add, you move it right, you subtract. So in this case, we're moving it to the right. So we move it to the right, we subtract. So 3, it'll be 3 minus 1, and that's a minus. Okay, and that's going to give us 2. And so then our final answer would be the same. It's going to be 9.24 times 10 to the second power. Okay. Let's try another one, and let's make it a negative number. So let's say we've got the 0.003472 times 10 to the negative fourth power. So again, we want it to look like this. We want it to look like 3.472 times 10 to the something. Okay, so I'm going to go through the first method. I'm going to take this whole thing out of scientific notation. So looking at here, when I'm taking it out, a negative 4 means I'm moving my decimal to the left. And in this case, 4 places. So it's going to be 1, 2, 3, 4. Fill those in with zeros. And then what that would look like would be 0.123, 123, 3472. So now that I'm taking it out of scientific notation, let's put it back in. So that's going to be 1, 2, 3, 4, 5, 6, 7. So I would then have an answer of 3.472 times 10 to the negative seventh power. Now to do that the other way, the more abstract way. So my decimal's here, and I know that I've got to make it look like this at the end. Okay. I'm going to look at this, and again, I'm going to use the rules as if I'm putting it into scientific notation. So I'm going to move this 1, 2, 3 spaces to the right. So if I move it to the right, I subtract. Move it to the left, I add. So I am going to subtract in this case. So it's going to be a negative 4 minus 3, which is going to give me a negative 7, which is 100% correct in what we got last time. Okay. So those were the biggest issues that I saw, or that was the biggest issue I should say that I saw, was it just seemed like we were having an issue of putting numbers that were already in scientific notation, incorrect scientific notation at that though, and putting it into correct scientific notation. Let's just do one more, just for all the kicks, you know. Let's say we got 0.023 times 10 to the positive 6th power. So just kind of going to speed through this. I know that my answer needs to look like this. Using the first method, going to take this out, so it's going to be 1, 2, 3, 4, 5, 6. So it's actually going to be 23,000. This is my actual number. And I got to put that back into scientific notation, so it's going to be 1, 2, 3, 4. So my answer should be 2.34, or sorry, 2.3 times 10 to the 4th power. I'm going to double check that with the other method. I'm going to be moving it 1, 2 to the right, and then 6 minus 2 is 4. That's exactly right. My answer would be 2.3 times 10 to the 4th power. Okay, so that's the biggest concern. My second biggest concern is going to be the multiplying and dividing using, and then keeping both sig figs and scientific notation. So let's say I'm given this problem. I'm given 6.85 times 10 to the 4th power times 9.367 times 10 to the 2nd power. So remember in the notes I said, you know, you want to really, what you should do is this, you know, you can plot this in this whole thing into your calculator, but this manner, again, this is kind of like the same method that I just, or this is kind of set up the same way as what I just showed you with just putting things in scientific notation. There's like two methods we could do here. One that is a bit more straightforward, but takes a bit more work to do it. One where you can just pop it into the calculator and then see what the answer is. I just be careful with that. Again, like I mentioned in the notes, that you know the calculator is not going to give you the correct answer every time. So be careful there. So in this one, what we're going to do is we're going to multiply just these values. We're going to ignore the times 10 to the 4th power. We're going to ignore the times 10 to the 2nd power, and we're just going to multiply these. So it's going to be 6.85 times 9.367, which is going to give us 64.16395. Okay, that's what our calculator should give us. Now what I'm going to do is that I'm going to quickly put this into the correct number of sig figs, just to get it out of the way, because it needs to be in the correct number of sig figs. So we've got 4 sig figs over here, and we've got 3 sig figs over here. So this answer needs to have just 3 sig figs. So I'm going to, again, count from left to right the number of sig figs I need. So it's going to be the 6, 4, and the 1. I'm going to look what's to the right of the 1. I'm going to see if it's 5 and above, or if it's below 5. It's a 6. So in this case, it is above 5. So I'm now going to round up this 1. So I should have 64.2. And now I need to worry about my scientific notation. So my scientific notation here looks like it's going to be this, and remember you're going to keep the times 10 no matter what. And what we then are going to look at is you know, what the exponent's going to be. So when we have multiplication, that pretty much means we're going to add our exponents. If we have division, that's going to be subtracting our exponents. So in this case, it's 4 and a 2. So it's going to be 4 plus 2 is 6. So it's going to be 4 plus 2 is 6. So then initially, we would have something like this. 64.2 times 10 to the 6th power. But we're not done yet. We need to make sure that we have this in correct scientific notation. So this is basically what we just did a little bit ago. So we're going to take this guy here and we're going to move it to the left. And again, it's like we're putting this number into scientific notation. And when we move our decimal to the left, that means we add. So that means here, since we moved our decimal place once to the left, so that's just going to be 6 plus 1. So then my final answer here is going to be 6.42 times 10 to the 7th power. And just to double check that on my calculator, let's see, it's going to be 6.85 times 10 to the 4th power multiplied by 9.367 times 10 to the 2nd power. And I'm going to get this big old number, okay? And then let's just to really show you, in the case that you have this selected, or if it does come up as a scientific into scientific notation, I would get, as it says here, 6.416395 times 10 to the 7th power. So there I would almost have my full answer. I would just have to change that to the correct number of sig figs, which again is going to be 6.42. Okay. So let's try another one. Let's go with 0.392 times 10 to the negative 7 or second divided by 0.0021 times 10 to the negative 4th power. Okay, let's see what that looks. Actually, the positive. Let's say the positive 4th power. Actually, so let's take a look at this. So again, let's just focus on these guys. So 0.392 divided by 0.0021. That's going to give us 186.6, and that's going to be, we're just going to say 6 repeating. So I'm just going to cut it off here because it's going to have to be 2 sig figs anyway. So we've got that down. So let's make this times 10. Go look at our exponents. Negative 2 divided by, or subtracting, or minus 4. So it's negative 2 minus 4. So that's going to be a negative 6. But we're not in the complete and correct scientific notation. So we're going to put it in scientific notation. Got to move it 2 spaces to the left. When we move it left, we add. So it'll be negative 6 plus 2. And that's going to give us a negative 4. And so our final answer here is going to be 1. Oh, and also to keep sig figs, I'm going to do that at the same time too. We're going to have 1.9 times 10 to the negative 4th power. And that would be our answer. So I got 1.9 because as I was putting it into correct scientific notation, I need 2 sig figs because there's 2 right here, and there's 3 over here. So because this is the lower number, my answer needs to reflect that and show only 2 sig figs. And in this case, I would count the 1 and then the 8, and then I look to see what's to the right of the 8, which is a 6. So I would round up. So I would have 1.9 times 10 to the negative 4th power. Let's plot that into the calculator. So it would be 0.392 times 10 to the negative 2nd power times 0.0021 times 10 to the 4th power. Oops, I put in something wrong. What did I put in wrong here? Oh, I multiplied, not divided. My bad. Oop, don't do that. Oops, I put it on the wrong spot. There we go. And then we would have our answer there. So we would have 1.86 repeating times 10 to the negative 4th. We would clean that up and we make it to 2 sig figs, which would be 1.9 times 10 to the negative 4th power. Okay. So that's pretty much, you know, when it comes to sig figs, especially the main things that you guys really need to work on and to focus on when it comes to counting sig figs, when it comes to scientific notation, that is it. So hopefully we're just going to spend another day. I'd like to only spend one more day. If we need to, 2 days on scientific notation and sig figs, and then we're going to move into dimensional analysis. So be prepared for that. Practice, practice, practice. Get a hold of me if there's something you guys don't understand. And whether that's email, Google Classroom, Remind, please ask away, request for a Zoom meeting, whatever it has to be. Please ask those questions, okay, guys? So without further ado, I'll see you guys in the next one.